Distribute.
Distribute, thank you. When we subtract, we must distribute my negative here. So I have 4x minus 7x cubed minus 6 minus 3 minus 6x cubed minus 10x squared. Alright, now that I've distributed, what do I have to do? Combine like terms. So I have my cubes. So that would be negative 13x cubed.
You can't take your no, what do you have to do?
Then we have a squared. Are there any other squareds though? No. So minus 10x squared. Then we have just an x. Are there any other x's? No. So we have just plus 4x. And then finally negative 6 and negative 3, which is minus 9. Alright, so it should be in standard form, and it goes from the highest exponent to the lowest, which we have done. So on one version, this is your answer number 1. On the other version, that's your answer number 2. Negative 13x cubed minus 10x squared plus 4x minus 9. So just mark the term that they got wrong in their answer. We're just marking right or wrong.
Wait, is that the same answer for both?
So on one of the versions, it's the first problem. On the other version, it's the second problem. I just reordered the terms.
Wait.
Yeah, it's like 4x minus 9. So again, if you see this problem on your little entrance ticket, this is the one you're grading. If you don't see this problem, then it's number 2. Alright, so based upon our classifications, monomial, binomial, trinomial, polynomial, and constant linear quadratic cubic quartic, what kind is this guy? How do we classify this? Let's look at our degree. What do we classify this as based on my degree? Cubic. And then based upon the number of terms. Drew, based on the number of terms, what do we call this? Good, polynomial. So they should have classified this as cubic polynomial. Okay. Any questions on how we went about doing that? Again, you're just marking the pieces they got right. How'd you get what? So once you've distributed your negative, you're now combining all your like terms. So that was a bad example. Negative 7x cubed minus 6x. Negative 6 plus negative 3. So after you've distributed, then you're adding all your terms together. Alright, our next one. We have 13 plus 2x squared plus 7x plus 4x squared. Oops, that's something. Plus 9x plus 1. Alright? Again, if you do not see this problem, then that's probably number 1. Alright, do we need to distribute anything?
No.
No, it's addition, so we can just go and combine like terms. I can remove my parentheses because there's no need for them if I'm not subtracting. There's nothing I have to distribute. There's no multiplication. There's no subtraction. Alright, so combine like terms. We have 2x squared and 4x squared. That gives me 6x squared. Then we have 9x and 7x, which gives me 16x. Then we have 13 and 1, which gives me plus 14. Again, it needs to be in standard form, and indeed we have it in standard form. Alright, so how do we classify this? Based upon its degree, what is it? Quadratic.
Those of us who are chatting should be
Trinomial.
Trinomial. Good. Quadratic trinomial. 3 terms.
Oh.
Alright, questions on that? Yes.
What if they put 16x squared?
I would just put a little line through that 16x squared. Just so they know that that's the piece they messed up on. Alright, questions on how to do these two. This is everything we learned last class. Not too bad. Alright, go ahead and give it back to the original owner. Now you see what you did wrong. I would highly recommend you go back through, look to see what you messed up so you know how to fix it. Since we don't have many quizzes, you're not getting feedback. This is your feedback so you know what to fix for your test.
Wait, what? I swear they're right. Come on, Jason.
Alright, I'm passing out your notes.
I'm positive you're not.
Again, look through your entrance ticket on your own sometime to see what you messed up, see if you can fix it. Come see us if you still don't understand.
Flag. Yellow flag. That's the Freddy. Can you text me? I'm pretty sure I got these.
Are they the answers that are up on the board?
Yes.
It's exactly what the board says.
You want your color pen?
6x squared plus 16x plus 14. You didn't even classify them.
I know for like the standard
Negative 13x cubed.
I'll
You have to go
them.
cubed, then squared, then single, then that.
Yeah. Oh.
So she, when she's saying that you flipped it, you flipped on this. I know.
Wow.
Alright, is there anyone that did not get worksheet 4?
Come on, man.
Alright. Let's dive into today's notes. Oh yes, please pass the colored pencils up front.
Thanks.
Oh, that's right. Homework. Thank you, sir. Okay, so today we're going to talk about multiplying and dividing polynomials. We just did adding and subtracting, so now we're going to do multiplying and dividing. We've already done multiplying monomials, and we've already learned distributing. So we're kind of combining these two concepts for our next one. Alright, so I need everyone's eyes up front, taking notes, paying attention, thinking about what we're saying and doing, and asking questions. Alright, so multiplying monomials. Negative 3x cubed times 4x squared. How do I multiply this together? What does it give me? Hey, don't laugh. You guys have absolutely nothing to offer me so far. Good. Negative 12. Good. X to the 5th. Elroy, can you tell me what you just did there? Good. So my exponents are added together because we're multiplying the same base. Drew, are we writing this down?
Yeah, it's not.
And then how'd you get your negative 12, Elroy?
Negative 3 times 4.
Good. So we multiply the numbers in front together, and then we multiply our variables together. And since they both are a variable of x, we can multiply them together, meaning we add the exponents. Alright, good. If they were different variables? 3 questions. So Gabby just asked, what if they were different variables? Let's say it was like this. If they were different variables, I cannot combine them. So I can multiply my numbers together, still get negative 12. And then I have x squared y cubed. So if they're different variables, they just stay as different variables multiplied. Good question. Alright, distributing. How do I distribute this guy? Philip?
Distribute the 2, you do 6x times 2, which is 12x.
Good.
And then negative 18
How'd you get negative 18?
by 9, negative 9 times 2.
Good. We distribute the 2 to both pieces. This is 2 times everything inside. So 2 times 6x and 2 times negative 9. Again, we're always writing these things in standard form. Alright, so remember when we multiply polynomials together, we multiply the coefficients. And what do we do with the exponents? Good. And make sure again, it's the same base. Exponents of the same base. Like Gabby asked about, they were different bases. We cannot add them together. Okay. So our first example. Let's go ahead and distribute this all out. So I have 4x times 8x squared. What would that give? 4 times 8 is 32. And x is what?
2.
2. Thank you. Alright, then I distribute it to my next piece. And Kathy, I'm going to ask you for help on this one. So 4x times negative 6x. What would that give? Yes, negative 24. 4 times negative 6 is negative 24. And Katya, what's x times x? And x squared. Alright, then distribute it to your last piece. 4x times 5. So 4 times 5 is a positive 20. And x times there's no other variable is just x. Make sure it's in standard form. Make sure you've combined all like terms. And here we've already got that. Okay, questions on that? Okay, so let's take a look at our next one. Our next one has 2 terms, and everything inside of here has to multiply to everything inside the other one. So everything in here has to multiply to everything inside of there. So let's first distribute the first term. I like to call this double distributing. Let me zoom in some. Can you guys see this in the back? So I'm going to first distribute my first term. So x times x, which gives me x squared, and x times negative 3, which gives me negative 3x. So I've just distributed the first term. So x times x is x squared. X times negative 3 is negative 3x. So I'm only distributing the very first term. We're about to get there. We're about to get there. I'm trying. Just want to make sure we're on the same page.
And remember when you glue these terms together after distributing, it's addition or subtraction. Because there's addition and subtraction in between them in the parentheses.
Yeah. So here's a term, we're adding subtracting. Alright, so now we have to distribute my 4. It's a positive 4 I'm distributing. So I distribute it to my x. And what's positive 4 times x?
4x.
Good. And distribute it to your negative 3. What's positive 4 times negative 3? Negative 12. But we have to get it in standard form and completely simplify. Alright, what's my first term going to be for standard form? Good, x squared. Now we have a couple of terms here we can combine. What's negative 3x plus 4x? Okay, positive 1x plus x. And then my last term, negative 12. And here's my answer. Okay, so we're distributing twice. Double distribution. Distribute your first term, then distribute your last term. Any questions on that? Okay, in the space off to the side, I want you to write in this next problem. 2x plus 3. Let's make that minus. 2x minus 3 times... Oh, we're giving this 5x Or give me something. Minus 6. Alright, so let's do this one together. Distribute your first term. 2x times 5x gives me 10x squared. Distribute it to your last term. 2x times negative 6 gives me negative 12x. Now I get to distribute again because everyone loves it so much. Negative 3 times 5x. So notice it's my negative 3 that I'm distributing. Negative 3 times 5x. Good. Negative 15x. Are you sticking with me, Natalie? Good. And negative 3 times negative 6. Good. Positive 18. Positive 18. No, there's nothing left to distribute. We already distributed both terms. Yes, now we combine it together, make it smaller. Alright, let's write our 10x squared first. Now, can we combine them in here? Good, what's negative 12 and negative 15?
Negative 27.
Well done, sir. Negative 27x. And what's my last term? Plus 18. It's in standard form, completely simplified, so that's how mine looks. Questions on that? Okay, so we have an acronym we use to help us remember this called the FOIL method. You'll hear us use this term over and over and over and over and over again. We'll say FOIL it out, FOIL it, FOIL it, FOIL it. So FOIL stands for first, your first terms, outside, your outside terms, inside, your inside terms, and last, your last terms. It's what we just did. Notice that when I did my first term distributed, those are my first terms, right? When I distribute again, look, those are my outside terms. Then when I did my second distributing, those are my inside terms. And when I distribute it again, those are my last terms. So first, outside, inside, last. It's the exact same thing, it's just a way to help you remember. So this is used all throughout all of your math classes. You'll hear them say FOIL. So let's go ahead and FOIL our first one. Alright, first terms. 3x times 2x, what's that? Beautiful, 6x squared. Outside terms, 3x times 5. X. Inside terms, negative 4 times 2x. Good, negative 8x. And last terms. Good, negative 20. Alright, let's look for like terms. Isn't that the sound that you hear when you circle your like terms?
Yeah.
Alright, so we have 6x squared. What's 15x and negative 8x? Positive 5x. Sorry. Positive 7x. And then my last term? Okay, and that's your answer. Alright, show me just in front of you, thumbs up, thumbs middle, thumbs down, how you feel with this one. 75, okay. Alright, so now I want you to try letter A and letter B. You can work with the person next to you. I want you to do letter A and letter B. Alright, so W times 2W is 2W squared plus 5W minus 6W minus 15. Now we combine our like terms, so we get 2W squared minus W minus 15.
Yeah, we got it.
Raise your hand if you got that one. Awesome, good job. Alright, now our next one. Negative 16A squared minus 6A minus 32A minus 12. Combine like terms, we get negative 16a squared minus 38a minus 12.
I got it.
Raise your hand if you got at least half of it.
I got it.
Raise your hand if you got all of it. Okay, good. Good job. All right. So now let's do example 3. Ooh, we have a lot going on here, don't we? It's actually still the same idea. All we're doing is distributing. We just have to distribute a lot. All right, Natalie, this one's going to be your favorite. Because we have to distribute and distribute so many times. All right, let's first distribute my first term. X times negative x squared.
Negative square.
Negative, whoops, I lost my negative already. Negative x to the what? To the third. X times x squared is x cubed. We should all be writing this down. Should all be writing this down. Alright, now x times 3x. 3x squared. Good. Alright, now x times 5. What's that give me?
5.
Good. 5x. Alright, we've distributed the first term. Now let's distribute the next one. Notice it's a negative 2. Negative 2. What are you doing? Oh, sorry. I was looking. I'm sorry. All right. Negative 2 times negative x squared. Good. Positive 2 x squared. And we're writing this down. Good. Now negative 2 times 3x.
No.
Negative 6x. Good. Now, negative 2 times 5.
Negative 10.
Oh, negative 10. Look at all of those terms. Now what do we do? Combine like terms. All right, let's start off with our x cubes. Do you see any other x cubes? No. All right, so that's my only guy. Let's do x squareds next. Positive 3x squared. Positive 2x squared. What does that give me? Good. Positive 5x squared.
Got it.
Next, we're combining our x's.
5, 6, 6.
So we have positive 5x, negative 6x. What does that give you? Good. Negative 1x, which is just negative x. And what's my last one? Good. Negative 10. And that's your final answer. It's in standard form. Hey, let's classify this guy. What type is it based on its degree? Cubic.
Yeah.
And what kind is it based on its number of terms? Polynomial. Polynomial.
Oh, yeah.
If there are 4 or more, polynomial. What about this guy here? What is this based upon its degree? Hey, Drew, what is this based upon its degree? But what does that mean? Which one of these? Good. Quadratic. All right, Elroy. What kind is it based upon the number of terms? Oh! How many terms are there? Oh, trinomial. Yeah, let's keep our giggling to ourselves, sir. All right, questions on this so far? All right, so now let's take a look at letter A together. We can do this a couple different ways. We could take each term and distribute it to my negative 4x squared, but I think what would be easiest is take this guy and distribute him. Right? It's the same thing. It's the same thing as if he was written in front. Alright, so let's do this one together. Negative 4x squared times 3x squared. Negative 4 times positive 3. Good, negative 12. What's x squared times x squared? X to the 4th. And we should all be writing this down. Right, Kevin? Alright, negative 4x times 2x. What's negative 4 times 2? Negative 8. X squared times x. Good, x cubed. Alright, and negative 4x squared times negative 6. What's negative 4 times negative 6? Natalie, you with us? Positive 24. And just x squared, right? Jason, are you writing this down?
Yeah,
You got it. All of it. Alright, can we combine anything? Yeah, what can we combine?
Nothing.
Nothing! They're different degrees!
Oh.
Is it in standard form? Oh, we're done. It's in standard form. There's nothing we can combine, that's it. That one wasn't bad, right? Alright, now I want you to try letter B. This is more like what we did up top. So do letter B next. Alright, so with B, we could do this again a couple different ways. I could distribute each of these. Or you can go from right to left. You could distribute these. Either way, we'll give you the exact same thing in the end. Okay. Just to stick with what we've been doing, I'm going to go from left to right. So what is 4x squared times 2x? What is
6x cubed.
I'm going to agree with your x cubed. 8. 4 times 2. 4 times 2. Good? Alright, now 4x squared times negative 5. Good. Negative 20 x squared. Alright, we've done our first term. Now let's do our next term. Negative 3x times 2x. What's that give me? Negative 6x squared. Now negative 3x times negative 5. Good. Positive 15x. You guys are getting better with your negatives and positives. Alright, and then finally our last term. Negative 1 times 2x? Negative 2x. Negative 1 times negative 5? Positive 5. There's a lot there.
If you would like to do back distributing, so 2x going into all three and then negative 5 going into all three, you can do that too.
Yep, just like I just showed you right beforehand, that'll do the exact same thing. Alright, let's combine like terms. Alright, let's start off with our x cubes. Are there any other x cubes there? Yeah? Where?
No.
No. 8x cubed. Alright, Drew, what's our next term? What do we have to do next? Our squareds. And oh look, we have a couple we can combine together. What would that give me? Negative 26, good. X squared. Remember, when we are adding, we have 20 of them, we have negative 20 of them and negative 6 of them, so we have negative 26. Alright, now 15x and negative 2x. Good, positive 13. X. And finally,
5.
plus 5. Okay, so if I were to classify this, I'm making you do more. If I were to classify this based on the degree, what is it? Cubic. And based upon the number of terms, what is it? Polynomial. Good. All right, questions on that? All right, flip it over. All right, you guys have been doing really good.
See, I told you it wasn't going to hold it up mine.
All right, dividing polynomials. So we should be on the back side of that page. We're on the back side on that page. After spring break. All right, on the back side of our notes, we're going to talk about dividing polynomials. When dividing polynomials, rewrite your polynomial so that each term. Let me zoom out. It's a little too close for comfort. So that each term of the numerator has the entire denominator. So basically what this is saying is that we're just going to break it up into our different pieces. Each term on top divided by the term on the bottom. So our first example here, 18x cubed plus 2x squared minus 6x to the 7th. Just like before, we were multiplying every single term. We are now dividing every single term. Everything on top has to be divided by 2x squared. Every single term. So we're going to break it up. Yeah, so let's break it up, guys. My first term is 18x cubed over my denominator. We should all be writing this down. So I'm taking my first term over my denominator. So kind of like this. Remember how we would do the I love division? Well, now there's a lot of different things. You like triple love division
Like
now.
Yeah.
Like the NBC4.
That's exactly what I was thinking. And hey guys, who can, so in the last unit when we were doing dividing, we just went right down with our like terms. Why didn't we do that one? Why didn't we do that one? What was going on the numerator between each of my terms?
She's talking about like this.
Yeah. So why didn't 4x get divided on each one? Why did we do that one differently?
Right.
Because the top is being multiplied, not added. Unfortunately, that's a common mistake that we switch up and think we can do equal on each one. They're not. They're different goals. Do different things for addition and multiplication.
Right. So when we have terms being added together in the numerator, each one has to be divided by that denominator. Whereas here, when we were multiplying, we just reduce to get our final answer. So when we are all multiplication, we reduce. But over here, we're adding subtracting in my numerator, so I have to divide each individual term. All right. So we've taken care of my first one. All right, now we need to do 2x squared over 2x squared. So plus 2x squared over 2x squared. So it's that guy. Now my last term. Plus negative 6x to the 7th over 2x squared. You can also rewrite this as minus, because plus and negative, same thing as minus. Right? Alright, so I should see everyone has this written down, broken up.
If you are struggling, come back and sit next to me and ask questions, or just ask questions tomorrow. Grab one.
Example number 2 is what?
Second.
Well, don't look at it. Okay, so now that we've broken it up, we simplify each one. Alright, Jonathan, help me out here. What does 18 over 2 give me?
9.
Good. And x cubed over x squared?
X.
Yeah, x. Remember when we are when we are dividing like bases, we subtract our exponents. Notice how what we just did last unit is coming into play here. It's kind of how math goes. What we just did comes back. Okay, what's 2 divided by 2? 1. What's x squared divided by x squared? X squared divided by x squared? It's 1. Good, Natalie. Anything divided by itself is 1. 4 divided by 4, that's 1. 6 divided by 6, that's 1. X divided by x, that's 1. Smiley face divided... No! I was on a roll!
Oh my goodness.
Smiley face divided by smiley face, that's what? Okay? Just kidding. Alright, so this whole thing becomes 1. 1. 1. What's x squared divided by x squared? 1. What's Elroy divided by Elroy? 1.
1 hour. Wait, then why does that actually?
Think of it this way. When we subtract our exponents, what do we get?
Oh.
What's 2 minus 2? And what is anything to the 0th power?
1.
1. Yes, Phil.
What about the first exponent? Like the first, like 18, x3.
What's 3 minus 2?
Okay.
That's the first. So x to the 0th power is just 1, and 1 times 1 is just 1. So the whole thing is just 1. Alright. So we have minus. What's 6 divided by 2?
3.
And x to the 7 divided by x squared.
That's fine.
Good, x to the 5th. Very good. Remember, we subtract our exponents.
Yeah,
Okay,
smarter
are
than
we
me.
done though?
No.
Why not?
Let's put it in order.
Yeah, we have to put it in standard form. What comes first? Good, negative 3x to the 5th. Then what? Plus 9x plus 1. Good. Hey, let's classify this. I know it doesn't say to, but I think it's good
No.
for you.
No.
Based
No.
upon the degree. Ooh.
So I keep 9x and not go with.
Yeah.
Are my exponents the same?
Yeah.
No, they're not.
No. They're not like terms. You have to have the same exponent in order for it to be like terms. Alright, anybody know what to call this one based on its degree?
Hello, Slico.
Does it have or for 5?
Remember, quartic was for 4, and it could be called quartic or 4th degree. What do you think this is called? 5th degree polynomial. Good. So this is a 5th degree. And based upon how many terms it has, what's that called? The number of terms here. True. Philip, based upon the number of terms, what's it called?
Trinomial.
Yes, this is a 5th degree trinomial. Alright. Example 2. Doesn't this look like a beauty?
No.
Alright, any questions on example 1 before we move on to example 2?
This is too much.
It's not too much, you just take it one piece at a time.
Yeah, that's
Alright, Natalie. I'm going to take my first terms and break it up together. So we have 18. 18x to the 12th y cubed. Please stop shaking the projector. Over my entire denominator.
Well, you
The entire denominator. We should be writing this down and not talking. This is going to be a difficult one, and if we keep talking, we're not going to get it. So the entire first piece over my denominator. Alright, my next piece. Plus 21 x to the 9th, y to the 5th, over the entire denominator. 6 x to the 4th, y cubed. So this whole thing was next. Carry that. Good! Plus, how'd you know how I was going to say it, too? 24 x to the 4th, y to the 6th, over my entire denominator. Okay. Now one piece at a time. 18 divided by 6. What does that reduce down to? 3. Yeah, 3. Alright, x to the 12th over x to the 4th. Good, excellent, good job. We subtract our exponents. Alright, now my y's. Y cubed over y cubed. 1. Okay, so times 1, which we don't really need to write times 1. Okay, see how nice that became?
Yeah.
How kind. Alright, 21 over 6. What does that reduce down to? 7 halves. These are each divisible by 3. Jason. 21 divided by 3 is 7. 6 divided by 3 is 2. So 7 halves. Alright. X to the 9th over x to the 4th. X to the 5th. And notice this does not go in my denominator, so don't write it underneath the fraction bar with the 2. It's being multiplied by it, not divided by it. Alright, y to the 5th over y cubed? Good, y squared. See how nice that one became?
No.
Okay, now 24 over 6?
Oh my god.
4. X to the 4th over x to the 4th? 1. So 4 times 1 just 1. Remember, it's the same thing. That becomes 1. And y to the 6th over y cubed? Y cubed. Okay, now standard form. This one's kind of weird with standard form. Remember Miss Charlotte talking about this last class? My x8, that's the highest exponent, so that comes first. Then x to the 5th comes next. This one doesn't have an x, so it comes last. So this is already in standard form. That's our answer. See, that wasn't so bad. Okay, now I want you to try A and B. Take it one piece at a time. Break it up and simplify. One piece at a time. You got this.
Oh, do we all?
The spring break.
It's your normal homework assignment. We didn't give you a packet, just a regular one.
Good luck. Good luck.
It's not homework over spring break because it's homework for today. Today's not spring break.
Okay, so 15x cubed over 5.
No, tomorrow. Actually, Monday.
So our first term over 5 plus 20x squared over 5 plus 5x over 5. So Jason, what'd you get for this? Jason Gloucester. Oh yeah, I wonder. Maybe we should be paying attention.
5x cubed.
5x cubed was 15 divided by 5.
What? Oh, hey.
3x cubed plus 4x squared plus x. Good.
I got it. Never mind. I just had that one.
Okay. Alright, any questions on that first one? Alright, now letter B. A little bit more work, but still not bad. 72x to the 4th over 3x squared
I got this one.
plus 81x cubed over 3x squared plus 9x squared over 3x squared. Jason, you want to redeem yourself?
Yeah.
Okay, go ahead.
24x squared.
24x squared, Jason.
27.
Good, 27x. Plus what? Good, plus 3. Very good. Good job. Alright, any questions on those? Alright, good. You guys did really well. Okay, next page. Almost there.
Can we just yeah, that's this is too much, man. What is this?
Alright, what is the formula for area of a square?
Length times width times height.
Can you say it again, please?
Times width times height.
Just length times width.
Oh.
If we had a cube, that would be it. Length times width.
Yeah.
Alright, so my area here, what is my length?
3x minus 1.
Yeah, 3x minus 1. Whoops. And that whole thing times my width. And my width is 2x plus 4. So the whole thing times the whole thing. So what do we have to do with that? Distribute, double distribute, or FOIL. So 6x squared plus 12x minus 2x minus 4. And then combine our like terms. We get 6x squared plus 10x minus 4. And that's our answer. Not too shabby. Alright, now who remembers the area formula for a triangle?
Base times width.
1/2 B I H.
Good. 1/2 b times h. What is b? Base. Here's my base, which of course we are all about. And what is my h? Height. Indeed. Alright, so area equals 1/2 times my base, which is 2x minus 30, times my height, which is x plus 7. Ooh, this is a little bit of a trickier one. So, we have 3 different things here, right? Let's first FOIL these guys out, and then distribute my 1/2. Otherwise, we're going to have to deal with a lot of fractions, and let's just deal with fractions at the end. Alright? So leave your 1/2 sitting in front, and let's multiply this out. 2x squared plus 14x minus 3x minus 21. Okay. Now, if we were to combine our like terms here, what's 14x and negative 3x? Good, positive 11. So these become positive 11x. Alright, so let's go ahead and distribute. What's 1/2 times 2?
1.
Good. So 1x squared is just x squared. Now, I went ahead and combined these together just to save myself room. What's 1/2 times 11?
5.
Yeah, we can't reduce it, can we? It stays as 11 halves. So plus 11 halves x. Again, notice my x is not in my denominator. It's just being multiplied. You can write on top if you prefer. 11x over 2. Alright, then 1/2 times negative 21. We can't reduce that either, can we? So minus 21 halves. That's your answer. Alright, now our final 2. Oh, look, they're multiple choice ones.
Yes,
Alright, letter C. They tell us that a white square means x squared, and a gray square means a negative x squared. So we have to figure out what this represents. Alright, so let's tally it up. How many white x squareds do we have?
4.
3, 4. Alright, so we have 4 of these. Alright. How many white rectangles do we have? 1, 2, 3, 4, 5, 6. So we have 6 of these. Do we have any little white squares?
No.
Okay, so far we have a positive 4x squared and a positive 6x, right? We have 4 of these, so 4x squareds, and we have 6 of these, so 6x. Okay, now we have our negatives. How many negative Where's we? Yeah, we don't have any of these, right? How many negative x's? 2, 3, 4. Alright, and how many little negative ones? Well, okay, you guys are fast. Alright. So we don't have any negative x squareds, but we have 4 negative x's, so negative 4x. And we have 6 negative 1, so negative 6. Alright, what does that combine together to give me? 4x squared. Good, plus 2x minus 6. Which one's that?
I told you we'll see.
C. Alright, now our last one, D. Notice that here they have factors. It's not actually multiplied out, is it? So we don't want to do the same thing. Instead, we want to treat this as a rectangle. They have it multiplied. It hasn't been multiplied out yet. So what's our area for a rectangle? Length times width. This is my length. And this guy is my width. Okay. So we need to figure out what my length is. Well, this represents an x. This represents an x. This represents 1, 1, 1. So what does x plus x give you? Good. 2x. And what's 1 plus 1 plus 1?
3.
Yeah, so we have 2x plus 3 is my length.
That's
right?
B.
That's this guy. And then what is my width? This represents x. So this is x plus 1. Right? My width is x plus 1. That's my width. So which one's that guy? D?
D, just like I said.
D?
You said D.
Alright, I'm going to pass out your homework to you.
Oh my god, we
Alright, so again, your homework is worksheet 5. There's a front and a back. We're being nice and making you only do the odds. If you do all of it, you can get extra credit. And as Miss Charlotte said, you need to show your work for these. The front side, the nut one looks like walnuts on there. That one you definitely need to do your work on a separate sheet of paper. The back side might have enough room. Right. Questions on that?
That's my